Okey, Assalamualaikum dan selamat pagi. Kita jemput grup pertama yang akan bentang pasal rotating disk electrode. Grup pertama untuk hari ni lah. Kumpulan berapa ni?
Kumpulan 4.
Kumpulan 4. Okey, silakan 4.
Assalamualaikum and very good morning. Today we want to play rotating disk electrode. Rotating disk electrode is a hydrodynamic working electrode that is used in free electrode system. Electrode system actually rotate during the experiment, including flux to electrode. The rotating speed of electrode can be controlled at different levels, which yield different flux of the analyte. So ni macam mana RDE tu berfungsi. First kali, the laminar flow is created during the rotation. Lepas tu bila sistem tu tengah rotate, the solution in contact with electrode is driven to the side of electrode. As the distance, some solution described as hydrodynamic boundary layer is tracked by spinning disk. This result in centrifugal force that flings the solution away from center of the electrode. The solution flows up perpendicularly to electrode from the bulk to replace boundary layer.
The function of RDE, the working electrode are used in electrochemical study in investigating the mechanism related to electrochemistry among other chemical phenomena. The more complex rotating disk electrode can be used as a rotating disk electrode if the ring is less reactive during the experiment. The flow can quickly exceed condition in which the steady state current is controlled by the solution flow rather than diffusion. Kalau yang ni, biasanya kalau DNA, CLE dan SSCC itu dia guna diffusion. So dekat sini, sebabkan kita ada movement of flow solution, dia akan bergerak dan kita takkan perlukan diffusion ni. So at various rotation rate, different electrochemical can be investigated such as multi-electrode transfer and electrochemical reaction. Next, history of RDE. Rotating disk electrode was developed by Benjamin Lewis at Institute of Electrochemistry. Lewis started the theory in his book, Review Chemical Hydrodynamics in Russia in 1962. Early 1960s, Stanley versus Spice and his students began working with rotating electrodes.
So next, structure of RDE. So kita boleh tengok body, second bearing, number 3 rubber housing, number 4 washer, 5 spring, 6 spindle for electrode, 7 pulley, that is retainer. 6 ni kita boleh tengok ada 3 different rotation. So the electrode include a conductive disk and then in an inert non-conductive polymer or resin that can be attached to an electric motor that has very fine control of the electrode rotation rate. The disk, like any other electrode, like any working electrode, is generally made of glassy carbon, graphite, carbon or noble metals such as platinum and argon. Dengar tak? Okay, next.
Ya, teruskan.
Okay. Untuk selection working electrode, dia ada 2 configuration. Yang pertama adalah configuration of analyte. special application RDE ni, dia ada untuk platinum electrode, dia sesuai untuk organic additive in platinum solution. Whole electrode untuk mercury and arsenic. So untuk ultra trace graphite electrode, kita boleh tengok boleh guna untuk trace macam cadmium, plumber, copper and yang lain-lain lah. Next. Second consideration dia adalah kita boleh tengok through window of potential. So through window of potential, half-wave potential of analyte ni, kita boleh tengok maximum possible working range of different electrode type. So daripada window of potential, kita boleh pilih electrode yang sesuai untuk kita buat analisis. Next. Okay. Thank you.
Okay, terima kasih grup 4. Alright. Okay, grup 4 saya soalan grup. Saya ada yang potential dia, analyte dia potential dekat 0.4. Boleh saya guna mercury tak?
Tak boleh.
Instead of maknanya boleh saya guna mercury tak?
Tak boleh.
Kenapa ya?
Mercury tu sampai 0.1 je dia punya window tu.
Sampai?
Sampai 0.1 je.
Berapa window dia?
0.1.
0.1.
Ya, tak sesuai lah. 0.1 je, sampai 0.1 je mercury, bukan 0.2 ke? Kau sampai berapa? Tengok mercury sampai berapa? Window of potential dia. Kalau electrolyte, kita betul tak? Kalau electrode, kita tengok window of potential. Faham tak? Faham So kalau window of potential bagi mercury sampai berapa? Positive voltage dia sampai berapa? 0.2. Tadi last ada table kan? Dah tengok table tu. Okey, berapa 0.2?
Tak sampai 0.2.
Okey.
Baru.
Okey. Alright. Okey, terima kasih. Kalau 4 ada soalan lagi tak daripada grup lain? Tanyalah. Nadia Idayu tak nak tanya? Nur Ismalina Ibrahim tak nak tanya?
Faham, Doktor.
Faham dah. Okey. Nadia ni senyap je ni, Nadia ni. Tidur ke? Kebangun dah?
Faham, Doktor.
Faham. Okey. Alright. So saya invite grup seterusnya untuk present. Group next.
Grup 5.
Grup 5.
Okey. Grup 5.
Dengar suara tak? Hello?
Dengar.
Okay.
Dengar, Mira.
Boleh start ke?
Dengar.
Mana doktor? Kita tunggu doktor kejap
So, kenapa belum present? Tak cukup orang lagi ke?
Saya tunggu doktor.
Saya tak tadi present.
Oh, sudah. Okay, tak apa. Saya start. Okay. Assalamualaikum warahmatullahi wabarakatuh dan selamat pagi kepada Dr. Faizwan dan rakan-rakan. Okay, we are from group 5 and we will present about normal pulse polarography and differential pulse polarography. So next. Okay, so this is the history of polarography. Dr. Jaroslav Herovsky has published his paper on studies with a dropping mercury electrode. He is the inventor of the polarographic method and also known as father of the electroanalytical method. He had received a Nobel Prize in 1959 for his recovery and the development of the polarographic methods of analysis. However, pulse polarography was first developed by Bakers as an outgrowth of square wave polarography. After that, Smith and von Stackelberg continued Bakers' work by summarizing his study.
Okay, so first I would like to explain a bit on what is polarography. So polarography is an electroanalytical technique that measures the current flowing between two electrodes in the solution to determine the concentration of solute and its nature respectively. So it is a type of voltammetry where the working electrode is a dropping mercury electrode or a static mercury drop electrode, which are useful because they have a wide cathodic range and renewable surface. Next. In general, polarography is a technique in which the electric potential is varied in a regular manner between two sets of electrodes, while the current is monitored. So the shape of a polarogram depends on the method of analysis selected, the type of indicator electrode used, and the potential ramp that is applied. So the majority of the chemical elements can be identified by polarographic analysis, and the method is applicable to the analysis of alloys and to various inorganic compounds. So polarography is also used to identify numerous types of organic compounds and to study chemical equilibria and rates of reactions in a solution. Next. So in pulse polarography, the potential is applied in the form of pulses and current is recorded in discrete manner. So there are three different types of pulse techniques: normal pulse polarography, differential pulse polarography, and square wave polarography. Next. The basis of all pulse techniques is the differences in the rate of the decay of the charging and the Faraday current following of a potential step, or known as pulse. So the charging current decays exponentially, whereas the Faraday current decays as a function of, like what you can see here, that is, the rate of decay of the charging current is considerably faster than the decay of the Faraday current. So the charging current is negligible at the end of the potential pulse. Therefore, at the end of the potential pulse, the measured current consists solely of the faradic current, that is measuring the current at the end of a potential pulse allows discrimination between the faradic and charging currents. There are few important parameters that we need to consider when using pulse technique, which are pulse amplitude is the height of the potential pulse, and this may or may not be constant depending upon the technique. And pulse width is the duration of the potential pulse. Sample period is the time at the end of the pulse during which the current is measured, and at the end of the drop time coincides with end of the pulse width. So what is normal pulse polarography? So normal pulse polarography consists of a series of pulses of increasing amplitude applied to successive drops at a pre-selected time near at the end of each drop lifetime. So between the pulses, the electrode is kept at a constant potential at which no reaction of the analyte occurs. So the amplitude of the pulse increases linearly with each drop. So the current is measured the pulse is applied only for 50 milliseconds at the end of drop time, while current is recorded just for the last 15 milliseconds at the end of pulses. And after each pulse, the capillary is mechanically tapped and mercury drop falls down. So the resultant polarigram is sigmoidal in nature, but it is of staircase type.
Okay, normal pulse polarography is a technique that uses a series of potential pulse of increasing amplitude. This technique is carried out in an unstirred solution. What is unstirred solution? Later I will explain about it. And the potential is pulse from initial potential, which is AI, where no redox reaction occurs, with sequence of increasing amplitude pulse where redox reaction occurs. The duration of pulse, which is T, is usually 1 to 100 milliseconds, and the interval between the pulse typically 0.1 to 5 seconds. Each potential step begins at the same value, and the amplitude of each subsequent step increase in small increment. When the mercury drop is dislodged from the capillary, maksudnya bila mercury tu dijatuhkan, dia jatuh daripada capillary tu, the potential tu dia akan return to the initial value dekat dalam preparation tu. Untuk ada preparation untuk new step. So the current measured tu initially before the application of the pulse and subsequently just before the end of each pulse. So the polarigram obtained by plotting the measured current versus the potential to which the step occurs. Next. So ini adalah graf untuk normal pulse polarography. So yang plus width tu, yang T tu antara 1 sampai 100 millisecond je. Dia punya interval, antara interval dua-dua tu 0.1 to 5 second. Drop lifetime dia 1 to 5 second. The current we measured is 10 to 40 millisecond after the pulse applied, at which time contribution of the charging current is nearly zero. So between the pulse, the electrode is kept at constant potential at which no reaction of the analyte occurs. And the limiting current in NPP is diffusion control. Next. So how does it work? NPP ni is a series of successively increasing amplitude are applied to a dropping electrode, and one pulse per drop applied at a time in the life of the drop. In the NPP, the mercury drop is held for most of its duration at a constant potential. So basically macam mana dia works ni sama dengan yang saya explain yang before this. Next. So yang dua-dua ni, yang satu ni graph excitation signal, yang satu ni adalah response curve dia. Yang tadi yang unsteady solution tu maksudnya mass transfer by diffusion. Sebab limiting current kita dekat dalam NPP ni kan kita kira pakai diffusion kan. So kita dalam NPP ni kita nak obtain limiting current instead of kita nak obtain peak current. Next.
Okay. Next is the differential pulse polarography. Differential pulse polarigraphy is one of the polarigraphy techniques. This technique that uses a series of discrete potential steps rather than a linear potential ramp to obtain the experimental polarogram. In this technique, a continuous increasing this potential is superimposed with pulse of constant amplitude. The pulse is applied only at the end of the drop at time 50 ms. The current is recorded twice during each drop. Then the current is recorded just before the application of the pulse and at the end of the pulse. The difference between the two currents is plotted as a function of baseline potential, which is E. The polarogram obtained consists of a peak instead of sigmoidal curve. The peak current or the peak height is directly proportional to the concentration of electroactive species. Next. Then the advantage of the differential pulse polarography. The differential pulse polarography completely eliminates Faraday condenser current and residual current become almost zero. The total current is recorded at the end of the pulse. Thus, the only contributor is Faraday current. And the detection limit goes up to 10 to the power of negative 8 molar. Yes. Seterusnya.
Dengar tak? Sorry. Okay, we continue with the DP. How does it works? Dengar tak? Dengar ke tak?
Yes, dengar. Silakan.
Okay, sorry. Okay, in DBP, the potential doesn't return to its constant base value after the potential pulse phase. So the return potential after each pulse is slightly negative from the potential prior to the step, and the base potential in between the pulses is increased at the same value. So the final current signal measured is the difference between the current before the pulse apply and the current just before the pulse end. Thus, DBP produces a peak rather than a wave, with the high current signal is roughly E half of DCP. DCP is direct current polarography. Okay, so two ways of pulse inputs in DBP are pulse on staircase scan and also pulse on linear scan. So as you can see here, the diagram between the difference between the two. So for the pulse on staircase scan, potential pulse alpha EP is applied for the pulse time 50 to 60 millisecond and then step back to a potential lower in amplitude than alpha E potential. And the other one, a constant but small amplitude potential pulse between 5 to 100 millivolt is superimposed on a DC potential ramp. The current is measured twice for the pulse on staircase scan, before and after the pulse is applied. And for the other one, the linear scanning allows user to create a fixed angle image, the same size as the probe, with in one dimension. So it is called electronic scan. The pushing sequence can create an image without physically moving the transducer.
Okay,
Next.
Next, the application. Okay, the first application analysis based on
Mai Sarah, tak dengar Mai Sarah.
the next application of pulse polarigraphy. Okay, the first application is for normal pulse polarigraphy. The analysis based on mechanical analysis
Still tak dengar je.
Dengar tak? Tak dengar juga.
Dengar.
Okey, dengar, teruskan.
Okay, the first application is for normal pass pornography. Okay, the analysis based on mercury ionization, sulfide and iodide. Okay, analytical determination of two level of sulfide. Expected result that long drop times and short pass with enhanced determination. Excellent technique for coping with and which is usually form from the surface of rock. Okay, the second application and the rest are for special pass determination. First, determination of heavy metals aim is to quantify the amount of heavy metals from three various samples using DPP with hanging mercury electrode. This study using standard addition calibration method. The second technique, determination of ascorbic acid in food substance. It aims to the aim is to determine the level of vitamin C in various food use, sample HNDPT with this study using external and standard addition calibration method. Next. Next are the determination the concentration of vitamin. The detection for various of vitamin, which is vitamin D, B2, nucleic acid, nicotinamide, nicotinamide, and ascorbic acid from 0.01 to 1 ppm, which is 10 to 100 times greater than DC level. Okay, the last application is analysis of solution containing surfactant. In the presence of the surfactant, the retain current obtained by DC through microscopy are less sensitive than DPP heat current. DPP heat current indicated ironically much stronger absorption of photo from
Tak dengar, Mai Sarah.
Doktor nak teruskan atau nak repeat balik?
Okey, sekarang comparison ni siapa?
Saya.
Amirah.
Amirah.
Okey, Amirah teruskan je.
Teruskan je. Okay. So this is the general summary where we can see the comparison between normal pulse polarization and differential pulse polarization. As you can see here, for normal pulse polarization, basically it eliminates the continuous varying potential RAM and replacing it with a new series of potential steps of short duration. Meanwhile, for different pulse polarization, DPP is used as a series of discrete potential steps rather than a linear potential RAM. Next, for NPP, each potential step begins at the same value of amplitude. Meanwhile, for DPP, each potential step begins at different value of amplitude, where it looks like a stair step. The return potential after each pulse falls to the initial value for NPP, and for DPP, the return potential after each pulse is slightly negative. The limit of detection for NPP is around 10 to the power of negative 7 to 10 to the power of negative 8, which relative to normal DC polarization. And for DBP, the limit of detection is 10 to the power of negative 8 to 10 to the power of negative 9. The difference between each pulse for DBP is around 1 to 4 seconds, while for DBP, the difference between each pulse is around 1 until 2 seconds. So that's all from our group. Thank you.
Okay, thank you. Ada soalan tak pasal normal pass dan differential pass fotografi? Okay, soalan saya, apa beza dia dengan metod voltammetri biasa untuk polarigrafi? Apa beza dia? The main difference.
Yang ni dia dah derive kan daripada voltammetri punya tu.
Macam mana derive tu? Voltammetri kan kita scan daripada kan potential negatif ke positif, dan kalau ada current, ni current peak kan, ada current peak macam tu. Tapi kalau kenapa polarigrafi ni berbeza? Apa main difference dia? Apa boleh jawab?
Kejap doktor.
Okay. Korang tahu tak semua slide ni kena hantar kat e-learning? Dah hantar ke belum? Yang dah present ni? Yang dah present minggu lepas dah hantar belum slide kat e-learning?
Belum.
Sila hantar ya. Wakil grup sahaja.
Doktor, yang voltammetri tu,
Okay.
yang voltammetri tu dia potential yang varied kan? Kan
Ya.
ke?
Dia scan potential tu, contohnya daripada negatif ke positif. Dan kalau ada analyte yang kena pada potential tersebut, yang apa nama ni, dia dan kita detect current itu mungkin meningkat, okay, sebab pada potential tertentu analyte tersebut mungkin berlaku redox reaction dia, okay. Dan apa beza dengan polarigrafi ni?
Working electrode ke?
Tak. Beza konsep dia, bukan working electrode. Konsep dia kan beza dengan voltammetri biasa, kan ada staircase lah apalah. Apa beza dia? Kalau voltammetri biasa, kita scan je dia punya potential tu kan. Kalau ada analyte, then kita nampak peak current. Tapi apa beza dengan polarigrafi?
Siapa?
Polarigrafi.
Sebab ada apa?
Ada interval.
Ada interval. Okay, interval, macam mana interval tu? Kan kau perasan kenapa potential dia naik turun ni kan?
Sebab yang diffusion mass transport ke?
Apa?
Yang diffusion transport tu ke? Dia pakai tak dapat.
Tak kan, kenapa kalau voltammetri yang kita scan potential versus current tu kan, Kan kalau tapi kenapa polarografi ni kita kena tengok dekat potential versus apa ni, time versus potential punya tengok staircase lah whatsoever. Kenapa kena ada macam tu?
Yang voltammetry ni dia
Okay.
kita ukur current dia sekali kan. Potential tu varied masa dengan current tu yang kita monitor.
Okay.
Tapi yang polarografi ni dia respon dia kita tengok dengan diffusion mass transport tu. Diffusion mass transport.
Okay. Itu beza dia. Main different dia.
Sebab dia kot lah.
Kot lah.
Ya, betul.
Okay, lebih kurang lah tu. Betul lah tu. Okay. Itu perbezaan dia lah. Tapi itulah kalau kita share dengan kawan, dia orang boleh baca lagi detail. Pasal kalau presentation macam ni kan kita dapat dengar tapi ada yang termiss dan sebagainya kan. Tak apa. Nanti ada lagi ke? Saya rasa masa tak cukup. Nanti saya explain on your presentation nanti. Perbezaan semua tu next class lah. Ini kita dengar dulu. Okay, dan kita kumpulkan slide dulu. Ada lagi group yang tak present?
Group 6, Doktor.
Group berapa?
6.
Ha?
Group 6.
Group 6. Okay, group 6 kena next week lah
Okay.
Kita dengar program next week lah. Okay. So saya dah okay, nanti group yang dah present semua untuk slide electrolyte, sampling electrolyte semua dah present. Okay, hantar dekat e-learning dalam bentuk PowerPoint. Okay, yang dah present untuk topik-topik yang ni pun sila hantar dekat e-learning juga dalam bentuk PowerPoint
Doktor, submission untuk next slide ni dekat folder SE. Dekat folder SE juga ke nak submit? Doktor tak buat lagi.
Bukan.
Maksudnya doktor create new folder ke?
Ada. You tengok untuk sampling electrolyte lain. Untuk presentation slide ni yang lain. Saya dah buat dah. Ada dah.
Okay. Thank you, Doktor.
Okay. So, kalau ada apa, sampai sini lah kelas kita. Okay, saya akan upload recorded class nanti dalam e-learning macam biasa. Alright, siapa tak scan attendance lagi? Dah scan semua? Ada seorang lagi tak scan, tak tahu siapa. 37. Siapa tak scan lagi?
Doktor, saya tak scan lagi.
Okay, saya share semula
Okey, Doktor.
Alright, kalau jumpa dan terima kasih semua.
Thank you, Doktor.
Sama.
Assalamualaikum.
Thank you, Doktor.
Terima kasih, Doktor.
Okay. Sama. Welcome.
Doktor, saya dah scan. Thank you.
Okay.
Thank you, Doktor.
Okay, sama.